move forward. Today's topics, sorry, let me just go to this. Today's topics that we're going to cover is I'm just going to give you an overview of Sass and why you might want to use it. And then we're going to talk about various variable types, which is sort of generic in some ways, but we'll talk about how Sass understands them. And then I'm going to talk about the actual data structure and how CYP C's data is structured, particularly when you get a request. I know there's some of you on the call who've actually already received some CYP C data from one of your requests, and it comes in many pieces, and it can be a little overwhelming, and we're going to talk about that and what that means. Then I'm going to talk about how you'd actually read in the data. If you're going to be using Sass, the reading in the data is pretty straightforward. If you're not, I'll give you some other options. And then I'm going to talk a little bit about creating and redefining some variables, subsetting the data if you want to remove some subjects from the data, and then ultimately working with dates and formats. And so hopefully this will lay some foundational work for us to move forward in the next series of talks around using Sass to analyze CYP C data to basically move us forward into more or potentially more interesting things around analysis. So just about Sass, Sass stands for the Statistical Analysis System. It was developed in the 1970s, and it was principally designed to analyze data and subsequently access and manage data as well. It's used by very large corporations, and we're going to discuss mainly the analysis aspects of it, but Sass actually does have a lot of database functionality that's highly tuned to business. And you can imagine as much as public universities use Sass and other organizations use Sass for analysis and other interests, they're a $3.2 billion company as of last year, and so they have a very long and strong foothold in corporations and companies that use them. One of the things that's interesting about Sass, actually, and for those who have used it or will want to use it and have access to it via their universities or institutions that they're at, is that you can never actually own Sass. So Sass, are, from the outset, the people who started it, actually still manage the company, and they decided that you could never actually own a copy of Sass. You could only borrow it. And so it's always done on an annual licensure capacity. So you will notice that whatever organization you manage to access Sass through, even if you buy it directly from Sass, you basically buy a one-year site license, and that license needs to be renewed every year. So don't be surprised when you're using it if it tells you that it needs to be renewed by a certain date. It will actually stop working. For our purposes, there are really just two major things that you can do in Sass, and this is just trying to sort of simplify Sass in the most basic of ways. But essentially there are data steps and there are procedure steps. And the data steps really are constructed so that you can manipulate the data in some way. So you can calculate things, you can drop variables, you can merge data sets, you can go through and sort data in particular ways. But essentially the data step is really how you manipulate the data. And the procedure steps themselves are really about analyzing the data. So these are things like getting frequency tables out and really managing output. So, you know, if you want to estimate a regression, for example, it would all be considered a procedure step. So today's talk and the things that we're going to talk about in Sass really are going to be focused on the data steps. So there's not a ton of output per se for me to show you. Towards the end, we will talk about formats, which actually are a procedure step, because it's about what the data looks like when you get it out. So a little bit about variable types in Sass. So there are three main types of variables in Sass. So you can have a character variable, a numeric variable, or a date variable. And these things are very, very important, and Sass is happy to store any of these things for you. The character variables are stored as text, as you would expect. So even if they contain special characters or they contain numbers, even if it only contains numbers, if it is considered a character variable or you establish that variable and it has a variable type of character, it will store it as text. And so what does that mean? It means that, you know, when you reference a character variable, even if it only has numbers in it, you can't add and subtract and do the things that you normally would with numbers, because Sass doesn't see it as a number. It sees it as text. And so when you reference data in Sass that are character variables and you say, you know, you want to subset your data and you have a diagnosis field that lists all the diagnoses for your patients, if you wanted a specific subset of those, you actually have to put quotes around the string that you want it to assess. And so in this example here that I've given you, you know, if you wanted to just in your diagnosis field you only wanted acute leukemia, you would actually have to type in acute leukemia and put that in quotes. And it evaluates exactly what's inside the quotes. And what I mean by exactly is that it is case sensitive. So if acute leukemia is spelled exactly the way that I have it here on the screen, it will find it and do whatever you ask to do with that. But say you put a capital A on that, or one of the variables has 2 spaces between acute and leukemia, it will not find it because it, as I said, evaluates it exactly. And so that's one of the difficulties sometimes with storing character variables is that it really can be a little bit difficult to work with in some ways. And so my preference is always to store data in a numeric format. So numeric format is just that the data is stored actually as a number. The problem with a numeric format is that you need to know what the value corresponds to. So if you're collecting something like blood pressure and you label it as blood pressure, well, I suppose you'd have to break it down as systolic and diastolic. But if you had systolic blood pressure, and that was the name of your variable, the number there, of course, already tells you essentially what it is that you're measuring in millimeters of mercury, for example. But if you have a whole list of diagnoses, for example, you would have to know what 1 means, you'd have to know what 3 means, you'd have to know what 6 means. And so in some ways, using the numeric variables takes a little bit more work in the sense that you really do need to keep a map, if you will, of what all the values actually mean. And towards the end of today's talk, we'll talk about format statements, which will help you do that. But the beauty of the numeric data is that you can do all the things with the numbers that you expect. So you can add and subtract and do all of the logical checks that you would expect to do with numbers. And in the analysis systems, in the procedure steps, it's a little bit easier to use the numbers because they evaluate numbers in a particular way. The final data type, this is not completely exclusive in terms of the data types that Sass has, but these are the 3 main data types. The final one is date. And dates are actually a special kind of numeric data that's stored. And a date in Sass, if it's actually a date variable, it's actually the number of days from a fixed point in time. And that fixed point in time is actually the 1st of January 1960. So a date variable is either a large, not necessarily large, but it's either a positive number or a negative number. And if it's a positive number, we know that the date occurred after the January 1st, 1960. And if it's a negative number, we know that it occurred before January 1st, 1960. But essentially, those dates are stored as a numeric value. And there's reasons why that is, and we'll get to that later on in the talk. So a little bit about data structure. So CYP C is a relational database. And what is a relational database, or what does that actually mean? Well, it means that there's multiple tables that contain data. And each table is usually designed in a particular way to capture a specific subset of the information that we may be interested in. So there's often a person table, there's often a diagnosis table, there's often a relapse table, there's a treatment table. And you know, all of these tables combined make up the database itself. The reason that this happens is that each table may actually have more than 1 record per unit of observation. So ideally in the database, we would not have more than 1 person in the person table. So each person is only represented once in the person table. So when we think about this, that makes logical sense. But when you get to the diagnosis table, you could have multiple diagnoses per person. And so the diagnosis table will have, it captures only 1 diagnosis per record in that table, but in actual fact, it could be linked back, multiple diagnoses could be linked back to a single individual. And this kind of expands out, if you will, across all of the tables. So you can imagine how you have diagnoses nested within patients, and you have treatment protocols that are nested within diagnoses, and you have various treatments that are actually given that are nested within the various protocols. And so this is how it kind of fans out, and it's all related, if you will, by some sort of linkage key that allows all the tables to be combined. And the linkage key itself is not necessarily the same through all of the tables. So all of the tables don't necessarily have all the same links to it, but they have the links that are required to be able to piece it back together and essentially rebuild the data as you may wish. So this is just sort of graphically looking at this. This is actually examples from a data request that Dr. Lillian Sung and I have. And so there's an info table that comes as part of the data request when you get it. And in our info table, we requested relatively little information. But in it, there's a CYP C ID, which is a numeric variable, and there's a gender and source variables. And then there's a diagnosis table that we have, and in this diagnosis table there's one record for every diagnosis for the population that we're interested in. And again here you'll see that the CYP C ID is repeated. There's a patient diagnosis GUID, which is a GUI ID. There's an ordinal primary number that tells us whether this is their first, second, third cancer. The ICD-10 code tells us the actual type of cancer that they had, coded to ICD-10 standards. Obviously, the diagnosis age is fairly straightforward, and then the definitive diagnosis date is at the bottom. But you'll notice that the one common variable that we have between these two databases is actually the CYP C ID. So this is the linkage variable that we can use to actually figure out what diagnoses happen to what individuals in our patient population. But going on and adding a little bit of complexity to this, you can now see that we have a diagnosis treatment plan table here. So this is going to collect information on every plan that every child has. And of course, if you think logically through this, there will be multiple plans even for an individual diagnosis. So the patient has an initial plan that's started, they run into problems either through toxicity, for example, and they initiate a second plan. So that treatment plan is stopped, another treatment plan is formed, and that gets entered into the database. Likewise, if the patient relapses, for example, they might stop that treatment plan and start a relapse treatment plan, and so on and so forth. Even potentially if there's a progression, they may change. So there's a whole variety of reasons why individuals with a particular diagnosis may have more than one diagnostic treatment plan. But you'll see here in the diagnosis treatment plan, again, it's one record per plan. And here we have the protocol name, we have a plan description, and we have the start date of the actual plan. These are not, I haven't shown you all of the variables that are included in these tables, but this is some of them. And then you'll see here that the CYP C ID actually is on this record as well. So we could link the diagnostic treatment plans directly back to the patient info, or we could link them to the diagnosis details. But if an individual has more than one diagnosis, which is reasonably rare, but still happens, if they have more than one diagnosis, how would you know what diagnosis treatment plans actually belong to what diagnosis? And this actually then requires you to link by both variables. So in actual fact, in this case, if you were going to put the diagnostic treatment plans together with the diagnoses, you would actually have to link both by CYP C ID and the patient diagnosis ID. And we'll explain this a little bit more, I think, in the next session 2 weeks from now when we talk about merging data in Sass. But I hope this gives you an overall view of what is kind of expected or what you might expect when you see the data and why it's in so many pieces and why you have to put it together. So the key to this, I think, is really just to think clinically about the data. And really, can you have multiple records of a particular event that you're interested in? And if you can, it probably means that there was a separate table that was established for that. The key with being able to put all the data back together is to actually know your linking variables between each table and other tables. And as I said, in the example, the diagnosis gets linked to the info table, the patient table, just by the CYP C ID. But if you actually wanted to link the treatment plans with the diagnoses, you have to link both by CYP C ID and the diagnosis IDs. So you really need to know what those linking variables are, and as I said, they may be different for different parts of the data. So speaking now specifically about the data structure of a CYP C data request, the data, currently as they're filling the request, it arrives both as a set of tables, so all these multiple tables for all the pieces that you might have asked for. You don't get the entire database. You get just the pieces that were required to run the analysis that you planned. And then you actually get a merged flat file. And what do I mean by a merged flat file? Well, a merged flat file assumes some sort of denominator or population. And then what it does is it makes it so that there's only one record per whatever that denominator is. So normally it could be considered the person, but you could also imagine how you could make a flat file based on diagnoses. And that sort of depends a little bit on the way that you've requested the data and how you've structured that. But essentially what happens when you create a merged flat file is that you have repeats of variables to accommodate the denominator. So as an example, if you figure that the denominator is a person in a merged flat file, the merged data set then has one record per person. And if in your population you have multiple diagnoses per person, there will be multiple variables in the data set that are referring to all of the variables that you were interested in for each diagnosis. So basically the data set is actually getting much wider instead of longer. So instead of appending more observations, we're actually appending variables out to the side. And so what happens is that you'll get ICD-10 code 1 for the first diagnosis, and you'll get ICD-10 code 2 for the second diagnosis, and 3 for the third diagnosis, etc. And so depending on what the total number of diagnoses you have for this patient, you will end up with multiple variables. So when you create these merged flat files, you can end up with data sets that actually have thousands, tens of thousands of variables in them actually, because it basically has to create repeats of the variables that you're interested in. And sometimes it's very useful depending on the analysis you're doing and the data structure that you want to use, and sometimes it's not. So, excuse me, CYP C basically provides it in both ways for you. So you can decide whether you want to use the merged flat file or whether you want to create an analysis data set that actually pieces together all the individual pieces. So how would you actually go about reading in the data then that CYP C provides as part of their data request? So now we're going to actually look at some Sass code. So I'm going to walk you through all of the various components of the Sass code just to let you know what it's doing. So this is the Sas Code that I actually run. This is was looking at some clinical trial data. So this is a project that, as I said, Dr. Lillian Sung and I requested some data for. And so the first line here says options. So in Sass, there's an options command that allows you to set a number of parameters up front when you're running some data. And so here it says ls equals 120, and that actually refers to something called the line size. So I've actually told Sass in advance that anytime it prints out anything, I don't want it to print more than 120 characters per any one line. And then the next thing says page size equals 67. Page size refers to the number of rows on a particular page. So I've told Sass here, don't put more than 67 rows on a particular page. So if I ask for a printout of the data, it's only going to print 120 characters maximum per line, and it's only going to print a maximum of 67 characters per page. And I know when I choose that, that's kind of what fits on my page if I'm printing at a particular size of font. Sass doesn't care how big or how many characters you want per line or how many lines you want per page. It's happy to do whatever you like. You just need to tell it what it is that you want. The next thing here says no date. And so this Sass generally puts the date on every page as it prints, and I just said to Sass, just suppress that for now. I don't want you to put the date on. And then I said page number equals 1. So every time I execute this line, it will reset the page number equal to 1. So sometimes when I'm running Sass, it can build up in the page numbers and I delete them, and it just keeps creating a sequential page number. But ultimately, every time I execute this command, it basically resets the page number to this. And then the next command is actually called no formatting errors. And there's reasons why you would run into formatting errors. The format isn't available and various things like this. And we'll talk about that later when I introduce formats to you at the end of this talk. But this basically just says ignore any formatting errors because sometimes they can just be a little bit frustrating. The next just says to put a title on every page. It says exactly what's in the quotes there. And on the footnote, it says here, add a footnote to every page that says this is the file that I'm using. And it actually puts the date on it. You'll notice that there's an ampersand sys date at the end. Ampersand is a reserved character in Sass, and the ampersand basically means that it refers to some macro variable in Sass or some variable that's already defined. And in this case, it's the system date, so it actually puts the current date there. So that's why I suppressed it at the top of every page when I said no date in the options line, because I was actually already going to add it to the footnote because that's where my preference is to see it. So I generally start all of my Sass programs by putting this information at the top. It tells me what the information is that I'm analyzing, and then at the bottom it tells me the actual file name that I'm using. and the date that it was run, so that if I have output, I know how I may be able to go back and recreate it, for example. So the next one, I just put a lot of comments in Sass as well. So when you comment in Sass, you put a /* and then you write the comment and you put then a star and a slash, and anything between those /** is commented out. It shows up in green in Sass, and you can see apparently I can't spell because analysis isn't spelled correctly. But often I just write a fair bit of information actually in the comments, and in fact the comments tend to almost be like a novella when I'm finished in the analysis. But the fact is that I just don't have that great a memory. And so when I go back, sometimes I've spent several hours figuring out how to get Sass to do what it is that I want it to do, and I need to write notes about that because a week later, a month later, 6 months later, a year later, when we're finally publishing this, I just can't remember why we did this or how I was even doing it. So I just would encourage everyone as they're using Sass to put in as many notes as they possibly can. So the next commands that I give is a lib name statement, and these are just library names, and these basically are just shortcuts for Sass to say when you reference lib name I, it just actually points to a particular directory in your system. And likewise, I've named a library, and in actual fact, it points to the exact same file structure in your file system. And I'll explain why I have two of these in a second. But this basically is just the location of where your data is located, so that you can always reference it basically via shortcut by using the lib name statement. So now I'm going to build the analysis data set from all the pieces. This is the way I would choose to build the data set. And so as I said, there were two kind of procedures essentially that you can do in Sass. The first one is the data procedure, and the second one is actually the proc procedures. And here you start a data procedure always just by saying data. And so here I'm saying data D1. So I'm actually creating a data set called D1, and I'm setting inside that data set a data set called I.diagnosisDetails. The I dot refers to actually the lib name above, and so it says, when I say set I dot, it starts to look wherever the lib name I points to. So it's looking in H CYP C projects trial data. It's looking in that folder for a file name called diagnosis_details. So this is where all those individual pieces are located, and really I'm just creating, as I said, with that lib name a shortcut so I don't have to type out that project directory every time. So it says create this data set called D1 and set inside it the diagnosis detail. And then there's a number of additional statements here which I will unpack as we go through and you kind of see what happens. But essentially here I've actually just read in the diagnosis details. The next part here is I delete anyone that does not have a definitive diagnosis date. Sometimes I'll check to see if that's the case. Sometimes I'll just remove them off the top. And then I actually just change the date into an actual Sass date format, and we'll explain that as we get down to date. So thinking about reading in the data again, one of the files that comes with the data request that you get from CYP C is an Excel file that has the proc contents of all the various pieces that you looked for. And the proc contents is what's at the top of this slide here. And so it tells me that I have a info data set, and I have it both in a Sass 7BDDAT file or a text file, so I have it in both formats. It tells me that there's 1,188 observations in the file and that it has a length of 12. The 12 just tells me that there's actually 12 characters of data stored for every line in the data set. And then down below it tells me the variables that are actually stored and where they're stored. So if you actually wanted to read in, if you're reading in the Sass file, the .sass7bdat file, you don't actually need to specify that as we've done here. You can just say look for diagnosis_details, and it will always look for the Sass file, the data stored in the Sass format. But if you were trying to do this in another project, or you have other data that you're trying to bring in that's in a text file or in an Excel file, you might have to read in data using a different set of commands. And for this, you actually have to specify a little bit more to Sass. So I know what my file looks like, what my text file looks like up top, because that describes what the text file looks like. And down below is the Sas code to read this in. So I say data info, so I'm going to create a data set called info. And I'm going to say that the in file, the file that I want you to bring in or import, is basically this file located here, which is on the H directory, and it's called info.txt. And you'll notice that there's a semicolon after each set of commands that you execute in Sass. That tells it that that command is actually finished. So the semicolons and the locations of them are quite important as we go along. The second line actually then says input, and then you list the variables that you want to input. So I want to input the CYP C ID, the gender, and the source as outlined in the variables that we have that's part of the contents of the data set. And then you'll notice behind each variable I have some numbers and characters. And there it actually puts a $7 dot. And that $7 dot behind CYP C says, read this in as a character variable. The $ represents characters in Sass. It says read this in as a character variable that's 7 characters in length. And then it reads in gender, and it says read in gender that's 1 character in length, and source as a 4-character variable. And you'll notice that I got the type of the variable right there out of the proc contents, and I got the length of the variables as well from the proc contents. So when this runs, you basically tell us where to look in this text file for the actual data pieces that you need. So this is just an alternative to reading in the Sass files. If you're working in Sass, I would just encourage you to use the Sass files as they are. It's just so much easier than trying to retype all this information. But as I said, sometimes you want to bring in additional information either via Excel or some other text file. Excuse me. If you did actually want to import Excel data, you can use one of the procedure functions. So this is the first procedure that I'm going to talk about today, and it's called import. So you simply call it by saying proc import, and this is the text, the code that you would need in Sass to actually import an Excel file. So I'll walk you through this. So you say proc import, and that tells Sass that you're going to now run this procedure called import. And the output data set I want from this procedure is to equal C1. So I'm going to read in the data set from some external data source, and I want you to create a Sass data set called C1. The data file itself that I want to read in is then specified in quotes. So here it's just whatever the name of the data set is in an XLSX format. The next command says DBMS, which just tells it the type of database or data format that you're actually reading in. So DBMS equals XLSX, so that just tells it that you're reading in an XLSX file. And then the replace command at the end of this just says if you're going to run this more than once, it would actually just replace the data set. Every time you ran this piece of code, it'll just read in and replace that data set for you. If you leave out the replace thing, it'll give you an error if you try to run it a second time, because it'll say that data set already exists and I don't want to replace it. The next command just says sheet equals, and in quotes, you type in the sheet in the Excel file, because in Excel, if you're familiar with Excel, you'll notice that you can have multiple sheets in every Excel file. So you just have to say what sheet the data is located on. And then the get names option just tells it that the first row of the Excel file actually contains the names of the variables. And sometimes that's true and sometimes it's not. So you can either say get names equals yes or get names equals no. So that code would actually import the Excel file. The other thing that sometimes you want to do is you want to export some data that you already have in a Sass data set into an Excel data table. And the export feature is just outlined below. And it essentially follows very similar to the import procedure, except now it says proc export and the data equals C1. So this is the Sass data that you want to use. And then the out file instead of the data file. The out file is the file name that you actually want it to go to. So a little bit about creating and redefining some variables in Sass. So data D1, and we've set inside it the diagnosis detail. Maybe I want to create a flag for early and late diagnoses. In this particular data set, we have diagnoses from 2001 to 2006. And so you'll notice here that I create a comment that says this is what I'm going to do in this little bit of code. And I say if the DX date is greater than or equal to the 1st of January 2001, but less than or equal to the 31st of December 2003, then early equals 1, else early equals 0. So let me just walk you through this. So when you have an if command is really just asking Sass to logically compare some data. And here we're asking it to compare the data that's stored in DX date against a few other dates. And the way that you can either use other variables that are already in the Sass data set to evaluate them, or if you have other dates that you want to read in, you can just type in what you want it to evaluate. And in this case, I wanted to evaluate dates, and so I type in the date in parenthesis and then put a D after it, and that tells Sass to convert that basically to a Sass date so that it can evaluate it against the diagnosis date.
Yep.
So we have an if statement that evaluates
what we can do that.
Some sort of condition, and then there's a then statement that says what to do if the condition is true. So if that condition is true, then you will do this. And the then statement says early equals 1. Well, in this particular instance, I've just created a variable called early. And that's as easy as it is to create a variable in Sass. It's just to specify it and say what it equals. So if this condition is true, then this new variable early is going to equal 1. And then I go on to say if this condition is not true, else early is going to equal 0. Excuse me. There are a number of other ways that you can do this. And you can see here that in actual fact, I'm creating the variable early with exactly the same values, except I'm using a different date range. So here I'm saying, look, if it's between the 1st of January 2004 up to and including the 31st of December 2006, then early equals 0. But then else early equals 1. So that's exactly the same, just coding it in reverse. So it doesn't really matter what you do. These two statements basically are equivalent. The other way to potentially do this is to create two separate statements. So instead of using the if, then, else set of statements, you could just use if, then statements. And you could say, if the first date condition is this, then early equals that, and if a second date condition is this, then early equals that. So all three of these are just different ways, essentially, to code the exact same thing in Sass. So one of the other things that Sass allows you to do is to basically shortcut some of the things that you might want to do. So here, I'm trying to code multiple ICD-OM codes. So I'm not going to get into detail about what ICD-OM codes are, but ICD-OM codes basically specify exactly the type of diagnosis they are. They're an international standard that's published by WHO. It's a 4-digit character, and basically here I'm saying if the ICD-OM code is in, and in is just another way to say it equals, but the in statement tells it that I'm actually now going to give it a list. So in parenthesis, I can actually give it a list of values that I want it to compare against. And so here you'll notice that I've used 9820, 9823, 9826, 9827. And then I get to 9831, and then I put a semicolon 9837. And it just basically says anything between those two numbers. So that semicolon includes 9832, 34, 35, 36, and 37, and so on and so forth. And now I'm using an AND statement because now this is still an if-then statement where I have some logic that it's trying to confirm, but now I'm compounding the logic with an AND statement. So I'm saying if the ICD-OM code is equal to anything in this list and the ICD-T code, which is actually the location of the tumor, is anywhere in this list, so between 000 and 809, then it will equal this new variable called DX group. In actual fact, the T code there that I've listed is actually all of the T codes that are available. And this is actually the code that's required to code or to convert ICD-OM and T codes into some of the diagnostic groups that you might be interested in. So all of these codes actually refer to ALL. So this then would take all of the diagnostic codes that we have in this data set and create a new variable called DX group, which is now equal to 1, and I'm in a comment I'm saying that this is actually equal to ALL. So I've created my first diagnostic group, and I've grouped anyone who fits this description and called it DX group 1. The second set of code follows exactly the same thing, except you'll notice that it's different codes, and now I've created it as DX group 2. So anyone who fits this condition that's evaluated in the if statement is then equal to 2 in the DX group variable. And this actually refers to AML patients. The reason why this code's a little bit shorter and uses this in statement and is you could actually run a whole series of if statements. So this is actually equivalent code to code the AML group, but you'll notice that you have to repeat a lot of things. It's a lot more typing, and there's a lot greater potential for some errors to creep in. So it's a little bit cleaner to do this code, which is just a bit of a summary code, but in actual fact it's not wrong to type this code out. It just takes a little bit longer. So some people prefer this type of coding, particularly when they start coding in Sass, because it's so much more explicit, because that ICDOM code has to equal this value, and it just is a little bit clearer for them. But both codes are equivalent. So then thinking a little bit about subsetting data. So maybe you only want a data set that includes the late diagnoses, the diagnoses from that particular time period that we had defined earlier. So here I'm creating a data set called late. I'm setting inside it D1, which is that data set that we created that includes the diagnosis table. And you'll notice previously we had defined in D1 a variable called early. And so here I'm saying if early equals 0. So now it's only going to keep observations where early is equal to 0, which is equivalent to the late group. And the second command is actually saying data early. So it's creating a data set called early, setting in D1 again, and it's keeping only the cases where early is equal to 1, so the true earlies, if you will. So now I've split the D1 data set into two, one that has late diagnosis and one that has early diagnoses. So this is just a way for you to basically subset your data. So the next set of code I'm showing you below here goes a little bit further, though, and it says, look, in the late diagnoses, keep all the late diagnoses where early equals 0, but also look at the diagnosis age and only take patients who are between the ages of 0 and 5, and only keep those where the gender is equal to M, or male. And equivalent code is down below for the exact, it creates the early data set down below, but essentially it's equivalent code for the DX age and gender. So here it's saying, in the if statement, it's saying where the diagnosis age is greater than or equal to 0, but less than 6. So that would be equivalent to 5, and that gender equals M. So they're just different ways of coding the same thing. So in the late data set, the second late data set, you would end up with cases who are only age 0 to 5 at the time of diagnosis and are male, and in the early data set it would be exactly the same, except they would be the early cases. So a little bit about working with dates in Sass. So as I said, dates in Sass are stored as a number of days from the fixed point in time of the 1st of January 1960. And the beauty of constructing dates in this way is it allows you to simply add and subtract dates. So if you were just to take 2 dates and you actually subtracted them, it would actually just give you the number of days between those 2 dates. And so that can be quite handy, particularly when you're trying to do these things. But sometimes you just don't want to know the actual days. You actually want to know some other metric of time. And there are a number of Sass functions that I'm going to talk about, yeardiff and incheck, that allow you to use Sass dates in a particular way. So just a little bit about adding and subtracting dates. Again, if you're interested in calculating someone's age, you might say that it's the diagnosis date minus the date of birth. And that would give you their age in days. But if you wanted to calculate their age at the end of some follow-up or some time period, you could just add that date in and say, look, how old were they basically on this particular date? So how old were they on the 1st of June 2016? Again, calculated in days. And that's the code that you might use for that. But what if you wanted to calculate things in years? Often we are interested in age in years rather than in days. And so here's the code to actually calculate it in days. And you could, theoretically, just take the number of days and divide by 365 and a quarter. So there's 365 days in a year, but there's a leap year, so when you amortize the leap year out across, 365 and a quarter gives you a rough calculation. The problem is that that's not terribly specific, and there are actually better ways to calculate age in Sass. And that's because they have functions in Sass. The first function I'm going to talk about is something called the yeardiff function. The yeardiff function actually calculates age in years based on actual calendar time. So here it says age equals yeardiff, and then in brackets there's 3 basically statements that you have to give it. You have to give it the 2 dates, so the first 2 periods, or the first 2 two things that you need to tell it are the dates that you want to evaluate. Here it's date of birth and diagnosis date. So it says how many years are between these two dates. And then the final one is how do you actually want to calculate this? So these are the third parameter that you need to give it are defined by Sass. And generally, I think the only parameter you might be interested in is actual. So this is actually looking at the calendar and figuring out exactly how many years would be, how old someone would be in years between these two dates. The reason that it allows other things is that Sass is very flexible, and Sass would allow you to consider a year being only, say, 30 days in a month and 12 months in a year, or more or less than that. You could actually consider a 13-month year if you wanted to. Sass is very flexible to allow you those things. But I think for most of our purposes, we're actually interested in the actual calendar time. So expanding upon this a little bit, maybe you're interested in calculating person time. And if you wanted to calculate person time in years, you might say, again, just using the year diff function, the first date I'm trying to evaluate is dx date, so sometime between diagnosis date and the end of follow-up. Well, the end of follow-up for most patients when we're thinking about person time usually occurs either at their death or at some date that we stopped following them. So here we would want to take the earliest of those two dates, the earliest of their death date or the end of our follow-up period. So if we were to imagine that our follow-up period was actually the 31st of December 2014, we can actually then use another function in Sass called min, and we could say, well, the second date I want you to evaluate is actually the minimum date of either date of birth or the 31st of December 2014. You could put as many dates in there as you wanted. So if you wanted to include relapse dates or progression or whatever other dates that you wanted to, you could create a list and it would just take the min. I should note that there's also a max function if you wanted the greatest date beyond those things. And again, then just the actual statement, and then that would calculate person time in years. But sometimes you want to calculate things other than in years. And often when I'm doing survival analysis, for example, I'm interested in calculating things in weeks. So days is a little bit too fine for me. I'm not really interested in what happens day by day, but I'm interested in weeks. And weeks become fairly important for the way that I do survival analysis. So I have to use another function called the int_check function, and it checks the number of integers between two time periods. And so if I was going to calculate that same person time that I calculated previously using the year diff function, I would say that person time equals int_check, and now I have to specify, again, just three parameters. The first one is, what is the time period that I want to be assessing here? So here I actually want to assess years. So what's the number of years between the two dates that I'm going to specify? And then subsequently you specify the two dates. So here it's the X date and the minimum of date of birth or the last date of follow-up. So again, this would calculate exactly the same that I showed you here on this page using the year diff function for calculating person time, except this is going to give me a little bit more flexibility. So this calculates it in years, but now I can actually change year to month, and this is now going to tell me how many months have elapsed between those two days, or date function. But maybe I even want it in weeks. Remember I said that weeks is the thing that I'm most interested in, often when I'm doing survival analysis. So the int_check function gives me lots of flexibility to calculate the difference between two dates. And in actual fact, these are the results if you use the int_check function to calculate the difference between the 1st of January 09 and the 1st of January 10. You can use year, so it would say that it's 1 year has elapsed, keeping in mind that it actually has to pass that date. So here, if it was the dates were the 1st of January 09 to the 31st of December 2009, the year, if you were calculating the number of years that had elapsed between those two dates, the years would actually be 0 because not a full year had actually elapsed. So it's only, in the dates that I've shown you here, a full year actually has elapsed between these two things. The other options are semi-year, so if you were looking for 6-month periods, quarters, you can look at months, which I already described, in weeks, and you can also look at days. So the int_check function is really a more flexible way to calculate differences in periods between days. And finally today, just a couple of things around Sas formats. So I said my preference is generally to store data as numeric. But the issue is that you have to remember what you coded things as. So the code that I had showed you to classify all of the ALL and AML cases together, I coded the DX group equal to 1 was for all the ALLs, and the DX group equal to 2 is all the AMLs. Well, you might remember that as you're coding this and for the first few days that you're working with this, but I can assure you that if you set this down for 6 months or you submit the publication and it takes them 3 or 4 months to review and then you come back and make revisions, you're not going to remember what those are. So the best way to do this is to actually use Sas formats to help both improve the readability to output, but also for you to basically keep a record of what those numbers actually meant when you were classifying them. So in using numbers to store that data, it takes up actually less space to store that number than it does to actually store a character variable. So I could have created, instead of saying DX group equals 1, I could have said DX group equals ALL and put ALL in quotes, and that would have told Sass that I wanted to store it as a character variable, and it would have stored ALL as the character variable. But that character variable actually does take up more space than actually storing the number. So if you're using lots of a large data set, using numbers to store the data as is actually a way to actually reduce the file size in some ways and make your processing faster. The other, as I said, is that actually storing values as numbers eases the analysis, because most of the procedures that we're going to use actually prefer that you have things in a numeric way and assumes that you have numeric data. In actual fact, there are a number of procedures that won't even allow you to go forward unless the data is actually stored in a numeric format. And hence why I just generally try to store everything. So in terms of Sas formats, there are 2 types of different formats that you can use. Some are user-defined and some are built-in. And you've actually already seen some of the built-in ones. But if you were going to user-defined formats, you actually have to start with a procedure statement, and you say proc format. So this tells Sass that you're going to use the procedure format that it knows. And here I'm going to refer to the library equals the library. So it just says, where do you want to store this information? Well, actually, I want it to store this information in the library called library, and I had defined that on the first set of code that I had showed you. And now I'm going to create a value for a variety of things. I'm going to create a yes-no value where the dot equals the missing. If it's 0, it's going to be no, and if it's 1, it equals yes. I generally always create a yes-no variable or format for variables. I'm going to create a variable for prime called prim, which is going to tell me the primary type, and so where 1 equals the first primary, 2 equals secondary primary. And then I'm going to create a value for agree. And the reason I'm just showing you this for agree is that actually you can have multiple levels of missing in Sass as well, and you can specify what those missings are. So in Sass, a dot in a numeric value actually means that it's missing. So you'll see that from the way that I've coded the missing for yes and for prim. But after the dot, you can actually put alpha characters, and that can be used to specify different types of missing information. And often we're interested in the difference between missing and not applicable. So sometimes the data is not applicable for whatever reason, and it's fine. I shouldn't be recording that because it only, that variable only happens to patients who have this particular diagnosis, so it's not applicable. Which is very different than saying that it's actually missing. So if you code it all as missing, it may look like you have a lot of missing information, but in actual fact, some of it just is not applicable, and that's okay. So if you're interested in knowing the differences between those, you can actually use both the .a and the format statements to tell you. The other general rule I use for formatting statements is that whatever the numeric value is, I put it in the text describing what that value states. So you'll see that under yes, no, I've said 0 equals, and then in the quotes I said 0 dot no. You're not required to set up your formats this way. You can type whatever you want between the 2 quotes, and it will apply that format. But sometimes I forget when the format's been applied, I don't know what I actually coded no as, or I don't know what I coded agree as. And so I always say in my in the text describing the variable, I always say what the value actually is, and it just speeds up a little bit later on when you're trying to, say, eliminate everybody that has more than a first primary, or if you only want to select people that agreed to a particular statement, you know that it's the, whatever value is storing that data is equal to 1. So how would you go about applying this? So this is the code that you need to actually create and store the formats in Sass. But then how would you actually go about applying it? Well, this is going back to that first time that we read in the diagnosis detail. So remember data D1, so we're creating data set D1. We're setting inside that data set I.diagnosis. So go out to file name, lib name I, and pull in the diagnosis details data set. And here I've just, as I said, I eliminated people with a definitive diagnosis where it was missing or not equal to missing. So I just kept people where it was greater than missing. I already used I converted the definitive diagnosis date into an actual Sass date. And then I dropped the definitive diagnosis date. I don't need to keep that variable anymore. But you'll notice here now I've created a format statement, and I said format dx date equals date 9 dot. So this is where Sass actually has built-in formats. So the date 9 dot format is something that's already built into Sass, and you don't have to specify it. And it just specifies to Sass that you want your dates output in a particular way. If you have a date value in Sass and you don't apply a format to it, what you will get is actually the number of days between January 1st, 1960 and whatever date you were evaluating. So that date actually tells you it's actually the number of days, and that's how it's stored. So if you don't apply a format, it's kind of hard to interpret the date because once it gets past probably about the 30th of January of 1960, I can't understand what the dates actually mean. So you can apply these already structured formats. The date 9 format is the one that I prefer. It puts 2 characters for the day of the month, and then it gives the month in character value, and then it gives the date of the year after that. The reason I like the date 9 format is because it doesn't put the month as a number. It doesn't show the month as a number, and I find that that's a little bit easier because sometimes when you're reading dates quickly, you can mix up the day and the month. And then I applied a label to this to say it's the diagnosis date. The next format statement says format the variable ordinal primary with the format named prim dot. And we defined prim dot previously here in that proc format statement. So it actually applies that format then to that variable. And so you can apply whatever formats you want to whatever variables, but you can only apply a single format to any one variable at one time. So just to give you a little example of what this may look like. So here's an example of what ordinal primary looks like. On the bottom of the screen is what it would look like without the format statements. So there's 1 missing, there's 11,984 who have a first primary, 132 who have a second primary, 7 who have 3 primaries, and 2 who have 4 primaries. And so you can see here that it's probably reasonably self-explanatory with ordinal primary. But when I apply the Sass format to it, if I run the previous code that I showed you and apply the format, what appears on the top is what I would actually get if I was actually going to look at the variable. So it would replace the dot and show me that it's unknown. And then it would replace the 1 with 1 dot first primary to basically tell me what it is. And so like I said, the formats help you basically provide cleaner output, and that's a little bit more self-explanatory. And this is the last example where we have dates. And you can see here that on the lower panel, it's showing you what the date is actually stored as. So dx date is actually stored as 14,976. And that means the diagnosis date for that patient is 14,976 days from the 1st of January 1960. And like I said, I don't really know what that date is because I can't do that kind of math in my head, particularly given leap years and all the rest of it. But if you look up top and I apply the format statement to it, that date 9 format, you'll see here that it gives me, it converts the 14,976 to 01 Jan 2001. So that's a date that I can understand. And like I said, why I like that date 9 format is because it puts the month not as a number, but puts it in actually as alpha characters. So these are the topics basically that I've covered today. It's just a little overview of Sass. I hope you have an understanding of the sort of 3 main variable types that you'll be dealing with. a little bit about the data structure and what to expect when you're reading in data from the CYP C data request should you use one. And then we talked a little bit about creating and redefining variables using if-then-else statements and use the if statements to also subset some data. And then I explained a little bit about working with dates and formats. So I'm hoping this gives us a great foundation to actually continue and talk about how to merge data sets next time and actually start working and manipulating the data a little bit further on our way to an analysis data set where we can ultimately do some analysis. So that was all I was going to cover for today.
Excellent. Thank you, Jason. We have a couple minutes if anybody has a question.
Hi, it's Tony here from Calgary.
Hi, Tony.
Hey, Jason. Thanks very much. That was a fantastic talk. I learned a lot from that. At the very beginning, you described that when you get data from FAC, you get these individual tables, and then you have a merged table. What are your recommendations? Is it easier to just use the merged table for everything so you don't have to go through and manually merge the individual tables?
So my recommendation always is to take the pieces and put them together, which
okay.
I know is a little bit more work because the merged table just seems so enticing because it's already merged. The problem is unless the merged table is established exactly the way that you want it, it can be a little bit more difficult to work with. And what do I mean by that? Well, sometimes I'm only interested in the first primary. And so all of that extra diagnostic information is just taking up space in my data set. So in actual fact, I'm only interested in the first primary, and so I would just delete everyone with an ordinal primary greater than 1 when I started to build the data set back. And I'll show you how to do this next time when we talk about merging data sets. The other thing is that when you get into some of the things that are a little bit more complicated, a little bit beyond what we've talked about today, complicated in the sense of the data structure, things like chemotherapy. So every time an individual there's basically when you get to the chemotherapy data, there's a separate record in the chemotherapy table for what was the total dose of methotrexate given. Well, I'm not that interested actually in the total dose of methotrexate. What I'm interested in is what's the total dose of anthracyclines in some cyclophosphamide equivalent, for example. And so I actually would take all of that data and I would take just the data table that has all that individual chemotherapy data and basically merge and manipulate that data exactly to the variables that I'm interested in, and then I would merge that onto the data set. And so you can imagine how if you were adding that chemotherapy data to the merged data set is just massive and can be a little bit overwhelming. So I just think you have a little bit more control, and I think it's just a little bit easier to figure out as you go along to piece it together. So that would be my suggestion. Any other questions?
Jason, this is Lindsay. I just wanted to ask a quick question about the computer requirements for Sass. I know previously you could not use Sass on Mac computers, but I know there's a new Sass software that maybe you can use with Mac computers with Sass University or something. And I'm wondering if you know anything about that and what your thoughts are.
So Sass University, so the Sass University editions usually do have a Mac version, so there is a Mac version available in Sass. I don't have any experience with it because I generally don't run a Mac, but I know it is available. So if your institution supports it, they should have the software available, and you should be able to download and install it either on a Mac or on a PC. So yeah, that's all I can suggest at this point, is to just check with your institution. I know it is available. As I said with Sass, so one of the oddities or interesting parts, depending on where you're standing, is that you can never own a copy of Sass, and so you can license Sass for a year. But in actual fact, you can license any portions of Sass or any products of Sass you want. And so some institutions may choose not to license the Mac version, for example, because it costs them more money. So most universities have negotiated a license with Sass that allows them all of the products in Sass, and so you can get it. But some other institutions, like hospitals, for example, may have only licensed the PC version. So I think it's really institution-specific.
Okay, I see. Thank you.
Jason, Tony here, and just a quick comment for Lindsay. There's also a program you can download for Mac called Parallels, and that lets you run a window where it's a Windows-based platform where you can run Sass within that Windows-based window. So, and you can do this at the same time as having your regular Mac OS running in the background. So, Parallels.
Okay, Great, thank you.
Very interesting. Stacy?
No, I was going to say the exact same thing. That's how I run Sass on my Mac.
There you go. Yes, you have a Mac and you run it, so there you go. So there are people who have solved this problem. But I think the latest version of Sass does have a Mac version, and if your institution has its license for that, it may actually run even probably a little bit faster than running these parallel versions. But there are ways to make it happen. Any other questions maybe just before we wrap up?
Yes, Emily. I wonder if we can use Sass to analyze with our local database. Do you think it's possible?
For sure. So, Rosemary, I'm not sure, or Emily, I'm not sure what the export feature in CYP C creates in terms of the data set that you get out. But Sass is very flexible in terms of how to read the data in. So basically, Sass will actually, through the proc import feature, would be able to import almost any data structure that it gave it to you in. So if it gives it to you in a flat file, like in a text file or in an Excel file or in an Oracle database or in an SPSS database, Sass would actually be able to read all of those things. So I think it would be available. It would just be a matter of figuring out what the export feature in CYP C does in terms of dumping out the data at the local site level.
Okay, great. Thanks.
Jason, is it possible for you to make your slides available, especially the ones with the Sas coding for all of us?
For sure, actually. So at the end of this, this has been recorded, this session, and the whole session will actually be posted online. And I can certainly create a PDF of the slides and make it available that can get posted alongside it if you don't want to listen to all the audio that goes along.
Perfect. Yeah, that would be excellent. Thank you.
Yeah. All right. Well, thank you all very much for joining. So the next session is scheduled 2 weeks from now, and a little bit over the summer we basically are speeding up the sessions, if you will, and we're meeting every 2 weeks just to get through some of this Sass information. So the next session will be in 2 weeks, and we'll just sort of continue on from where we left off and learn about merging data sets and using a little bit more complicated coding in Sass to be able to manipulate the data you may want to. So thank you all for attending, and hopefully we'll see you in 2 weeks.
Thank you.
Goodbye.
Bye, Ray.
Thank you.